Yeah, welcome to the lecture 25. This is about the DSAT model. Earlier lectures we have discussed about the concept and principles of the craft modeling, and we also have discussed the symbols used for the compartment models and the basic flow chart for a craft system model developed for the potential production simulations. We have discussed about the biomass growth and yield simulations in a potential simulation model. From this lecture onwards, we will be discussing very specifically about a software, that is a decision support system for agro technology transfer. So, this software will be used for the crop yield simulations, biomass, the durations, and this will be input management for maximizing the productions, and the process for the DSAT is in data inputs, simulation process, and the different type of the modules in DSATs, and the use of the DSATs for the solving the real world experiments, because in case there is no cannot do experiment with the quickly for decision making process, you can use this software for the proper management decisions in agricultural operations. So, today I will be giving this lecture will giving a brief overview about these DSAT models, how it was developed, who are the developer of these models, and what are the simulation processes in these DSAT models. So, with this so let us have this model overview, applications, and what are the crops included in this DSAT model. And this is the DSAT is the decision support system for agro technology transfer. So, this is the decision support system for agro technology transfer is a comprehensive crop simulation models. So, there are different models are available for the crop growth and the yield simulation, like UpSim is there, CropSys is there, InfoCrops are there. So, these are the different models. DSAT is the widely used model. So, this is developed through a collaboration among the particularly University of Florida, University of Georgia, University of Guelph, University of Hawaii, Iowa State University, International Center for Soil Fertility and Agricultural Development. So, in coordination means the data, the experimental data are collected for different crops and different conditions. So, looking at the experiment data sets, the model was developed. As you discussed earlier, model development, it takes long time, and the once you have the model is ready, then you can go for the applications and analysis. We have discussed about the scientific understanding the goals in crop modeling and simulations. So, DSAT particularly for the if you go for the objectives, so you will be DSAT for the engineering goals. So, not for the development of the model, only for the application of this model or the software for the problem solving, that means to have a better understanding about the interactions among the inputs and the effect of the inputs on the outputs, particularly depends upon the crop growth, crop yield, or the soil water balance, or the nutrient dynamics. So, accordingly you will be choosing the right management practices to have a the precise input management to have the maximum productions with the as a resource efficient production technique. So, this DSAT that integrate the multiple scientific discipline into a single modeling framework. So, designed to simulate crop growth, development, yield under diverse conditions. This is the scope of DSAT is designed to support agricultural research, farm management, decision making, and policy analysis. So, this model, because using this model, the output of the models based upon your the user interest, what type of the information do you need. So, that helps in the decision making process, and the particularly policy analysis, the policy level decisions. Using this model, you can support the policy makers for a particular country, regarding the agricultural production practices. And if you go for the yield forecasting for the future years, so that is essentially very important for the government peoples and the policy makers to understand about the future food grain productions and to have accordingly to have a preparedness for this also. So, this is a policy decision that can be formulated using this DSAT model. So, this systems what it does, it allows users to evaluate crop performance under different climates, as the climate condition, that is under different climates, and particularly for the if you go for the future years, if you are going for the to understand the effect of the climate change, rising carbon dioxide, rising temperature, variable solar radiations or variable rainfall on the crop production. So, different climatic conditions can be tested and the crop performance under the different weather parameters, different climate can be simulated using this DSAT model, and that gives you understanding if there is if future weather is known, then we can make an understanding, you can predict the crop productions, food grain production under the future climate scenario. That will be the requirement for the policy level decision making, the government officiaries and policy decision. And also agricultural insurance company also they need such informations about the climate abnormalities or the weather related abnormality, how it is going to affect the food grain production. This simulates under different the crop production under different soil conditions, there are different soil textural classes, soil properties. So, looking at the soil properties, this can provide the information about the crop performance. Crop varieties are as a different species of the crops. So, if you go for the sensitivity analysis for a particular climate or the changing climate or the soil conditions, the different varieties may have the different performance. So, looking at the if you go for the testing for the varieties, we can recommend particularly the varieties specific to a particular climate and particular soil conditions using these softwares. So, to because if you go for experiment takes a longer time and also there is a huge investment is required and also of course, a time taking process. So, with a limited time and with very limited expenses or no expenses, we can get information, generate information about the specific varieties, specific crops and suited to particular locality, particular weather and particular soil conditions. So, that indicates the management, so simulate the management strategies. So, what is the different management options to you change the managements. So, for a particular soil, particular climate and particular crop variety. So, we can change different management options. So, through this we can optimize the management or the location specific management, crop specific management or the soil specific management options to maximize production. So, that is what the beauty of the crop modeling and simulations. So, where this experiment takes long time and these simulations can give the information about the specific management options or the strategies for a particular locations, particular soil condition, particular climatic condition that can be understood using this crop model. So, that enables rapid simulations of scenarios that would otherwise require the long term definitely field experiments. So, which you can get within limited time, we can generate the informations, we can generate the data, we can have gain the knowledge about the management strategies for a specific crop, specific varieties in a particular soil and particular climatic conditions using this software. And so, this is a structure of DSAT modeling system. This is a collection of the independent programs that operate, the different modules are that operate together. So, major system components this include the crop simulation models. So, that is a crop growth and biomass simulations through this model. Soil and water balance modules, this gives the soil nutrient dynamics, nitrogen, soil carbon and the soil water balance, the rainfall, then infiltration, runoff, drainage from the soil. So, soil water balance model that is useful for the calculation of the that includes the evaporation, evapotranspiration calculations for the crops and the also water use efficiency for the crops. And this has the weather database because we provide this daily weather data. So, this weatherman is there that because weather is required for the simulation of the crop growth and development, of course, the soil nutrient and water balance, and the crop nutrient uptake. So, weather database is there. Then management input models, the management input models that includes the you can say the field experimental management. So, field management that starting from the land preparation of the tillage operations up to the harvesting. So, whatever the management practices, that is for the tillage, seed sowing technique, seeding depth, then the crop geometry, seed spacings, intercultural operations, that is say weeding, fertilizer management, water management, pest and disease management, then your then harvesting. So, these management modules are there. So, that is what they are, that is these are the this goes as a input to the crop, like soil is a input, weather is a input, management is a input, and then you can simulate the crop performance in this model. So, these components interact dynamically that represent the crop, soil and the atmospheric system. And see data requirement, if you see the data requirement. So, weather data. So, mainly the as you discussed earlier, the for the real world experiment, for the in the field experiment, if you go for the crop production in the field, you need the 4 major components, that is your the weather and the soil, then the management and the crop cultivar, cultivar. So, the 4 major components, weather is one, and the soil components, management components and the cultivar file, say crop or the genotype characteristic of this variety. So, these are the 4 files, 4 inputs goes to the crop models like weather, rainfall, solar radiation, temperature, carbon dioxide content, and the soil file that has the soil chemical properties, physical properties and biological properties. So, soil physical property, the water holding capacity, and that is a field capacity, wilting point, saturation, then soil nutrient contents, organic carbon, nitrogen, pH, phosphorus, these are cation exchange capacity, the soil chemical properties, and also soil biological properties are there. If you can include the soil microbial biomass, soil health, so that also can go as input to the model, and these are the weather and soil properties, and the crop cultivar, that is a genotype coefficients of the crops. So, it is inbuilt in the model. So, but you have to need to calibrate based upon your experimental informations, or you can estimate the cultivar parameters based upon the experimental understanding. If you have the field experiment, from the field experiment you can calculate the cultivar parameters or genotype parameters for a particular variety. So, that talks about the duration of the crop, the flowering dates, maturity dates and the growth and the yield genetic potential of this crop. So, that can be calculated through the field experiment. So, this then finally give the management inputs, that is a planting operations, the fertilizer management, irrigation management, then you have the plant protection measures, these are the management inputs are given, and we go for simulations, that is a crop growth, crop yield, crop water use efficiency, crop nutrient use efficiency. So, that is simulate. Along with that, we also simulate the environmental impact. So, because of this crop and the input management, what is the changes in soil fertility, soil nitrogen dynamics and the soil organic carbon contents, soil nutrient leaching and greenhouse gas emission, particularly CO2 emissions from the crop field, that can be simulated in this model. So, the inputs are the location specific and the users are defined. So, accurate inputs are essential for reliable simulation of the output. So, before that also, as we discussed also some classes. So, you need to know model calibration and validations, as you discussed how you must calibrate the model and validate model for the local conditions where you are applying this model. And the simulation processes and outputs in this chart, these are the this photosynthesis and respiration. So, these are the how the carbon dioxide intake in the plant is converted to carbohydrates and the for the accumulation in the plant, then the assimilates converted to the biomass. See, first the photosynthesis, this we have explained in the potential production simulation models. So, the DSAT also include the photosynthesis and respirations. So, net assimilates is converted to biomass accumulations and then partitioning. The biomass accumulated in the plant parts is partitioned to the below ground portions, root portion, and the above ground portion are the stem, leaf, and the economic parts are the grain parts. So, in case of course, the partitioning between the root and the above ground portion, so below ground and above ground portion, and above ground portion also the partitioning happens between the leaves, stems, and the storage organs, that is the economic part. So, this the partitioning that depends upon the stage specific, that is a growth stage specific, how much biomass can be partitioned to the leaf portion or the stem portion or the grain portion. It depends upon the stage or the crop growth stage, as well the partitioning factors. Then we have the water and nitrogen uptake. So, that is a simulation of the water uptake and the nutrient uptake in the model. So, water and nutrient uptake. Then fertilizers and the irrigation requirements. So, based upon the simulation analysis, we calculate this fertilizer and irrigation requirement, then nitrogen balance and the water use efficiency also simulated in this model. So, these are the process, small process and the in this model. So, how the model is DSAT is applied particularly. These applications of these models simulate the growth and the development using physiological processes integrated for daily and or hourly time step. Particularly, it calculates the daily time step basis, the crop growth, the biomass accumulations, the leaf weight, stem weight, and root weight, and the other organs weight in the plant parts. It is calculated on daily time steps as per the radiation interceptions and the temperature photothermal units are converted to the radiation gives the biomass, photothermal unit gives the duration of the crops based upon durations. So, the daily accumulation is calculated, daily time step calculation in the DSAT for the biomass accumulations. Then this support the real time decision making for crop management, including irrigation, fertilizer, and cultivar choice. So, the purpose of this applications of this model. So, we can use this model for the crop yield simulations before the season starts. So, we can know the what type of the crops can be chosen, what type of the in crops, if you choose a crops for a particular crop. So, what type of the cultivar or the specific variety to be chosen for a particular locations, and the management, the input management schedules starting from the land preparations to the harvest. So, that can be simulated before starting of the experiment, and also that can be simulated during the crop growing seasons. So, at the time of the planting, when you have the sown the crop or the planted the crop, you can simulate the expected yield of the crop at the time of the planting or the sowing. And when the crop is grown in the field in the mid seasons, we can go for simulation also. We can see how much yield is expected, and that gives us understanding any corrective measures in the input management to maximize the production. In case there is a the benchmark or the reference the yield, how much yield is expected, and the suppose the mid season simulation that shows there is a loss in yield. So, we can take the corrective measures, particularly the input management, water and nutrient managements, to maximize the production, to avoid the yield loss due to any abnormal conditions. So, this support the real time decision making. So, if you the crop in the field, you can run the model using the forecasted weather. See whether is available for the future periods. Using the forecasted weather, you can run the models and you can get the outputs, and based upon the output you can make a decisions regarding the input management. But please keep in mind that for any field crops, as per the duration is concerned, so input management is very specific, the time specific, the stage specific. For a particular stage that needs a specific type of the nutrients and the input management. Delay in the input management, that causes loss in production. For example, we have discussed for rice. Rice is a you can say determinant crops. For crops like rice or the wheat, where the flowering is very synchronous and you need not miss a stage specific input management. Suppose there is a stress of the nutrients at any specific stages, then one of the yield components will suffer because of lack of nutrients. So, it is very essential to see the stage specific input managements for a crops like determinant crops in rice. For non-determinant crops like tomato or you can say brinjals, where or you can say even okra, the vegetables, where fruiting comes as a in throughout the harvesting periods. You do not harvest the crop at a particular at one stage. Harvesting continues for the almost 15 days or the 1 month, depending upon the fruit comes up. In that case also, though it is very essential to maintain a vegetative growth. If you have a good vegetative growth, you can get a good reproductive growth. But there can be some type of as a if you miss some nutrient, there can be some type of management towards the end. But crops like determinant crops, they are very sensitive to input management, and if you do not manage inputs at particular growth stage, then you will be missing the productions. So, for non-determinant, though it some extent is true, but there can be some post corrective measures in case you missed the nutrient management at the initial stage, somehow it can be taken care, the crop can recover, but not in case of the determinant crops like rice or the wheat crops. So, that is why real time decision making is very important for the using the model. At the same time, your the practical experience, understanding about the crop phenology also essentials for the decision making process. Model can give output, but the decision has to be taken by the human being using the own experience and the practical understanding. This evaluate also the water and nutrient dynamics in soil crop systems, including leaching, runoff and organic matter decomposition. So, also assess the climate variability and climate change impacts. Already have discussed this one, crop productivity and food security. Enable analysis across different soils. You can use the model for the variable soils, variable weathers for different years. You can run the simulation for the coming 25 years, coming 30 years, if you have the futuristic weather data, or you can see the models performance in the past years weather also, and also you can use the model for the different location, multi-location trial can be tried using this model, and that gives understanding about the how the variability, the weather, variability in the soil or the variability in the locations that influence the production of a particular crop and the particular variety. This assists research by identifying the knowledge gaps in crop soil climate interactions. So, this is the support the genotype evaluation through calibration genotype coefficient parameters. So, using field data. So, as you discussed, the field data is used, you have the experiment data that can be utilized for the estimation of the genotype parameters in these crop models. And if you do not have the adequate field data for estimation of genotype parameters, so what you can do for using this model, that we will discuss in the hands on exercise definitely. So, if genotype parameters, a set of data sets for that indicate the genetic coefficients of this particular cultivar variety, that you can use in your model. If you do not have a proper experiment to calculate these parameters, that you can use a reference variety from the existing module available in this model, and that you can change as per your the experimental conditions. Desert version, this we have the this started from the from 1989 version 2.1, then there is a development, then came 3, 3.5, 4.7. So, recently we have latest version is desert version 4.8.5. So, this is available, the free download software, and this is a this model was largely developed using the Fortran language, but now this community, desert community is actively developing interface and the libraries in modern language to enhance its portability across the Windows platform or the Linux or the Macs, and that can be integrated with the R, Python and the JavaScript, particularly for the spatial analysis, make a very simpler process for the you have the spatial analysis map, spatial variability, crop yield variability map can be prepared using this RStudio also. So, the crop coverage DSAT has several crops in this model. So, now as of now there is around 45 crops in there in this model. This is applied globally across diverse agroecological situations. So, so different crops are there. So, the version 4.5 for 4.6. So, that includes the cereals and the legume crops, root, tuber and perennial crops. So, 4.7 this is also has many cereals, pulses, root and tuber crops, oilseed, forage crops, fiber, vegetables, sugar and the fruit crops. And recently we have the DSAT version 4.8.5. So, that covers all the almost 45 crops like cereals, pulses, root, tuber, oilseed, forage, industrial crops, and that includes the multiple sugarcane models also, so enabling system level applications. So, these are the the crop models, these are the crops, several crops available in the DSAT platform. So, most of the field crops you can see that is different locations also that is available. So, for the Indian condition you can find, so the major crops are available in the DSAT platform. And with this we can see the summary. DSAT is a definitely comprehensive is a comprehensive crop modeling and decision support system. So, it integrates the weather, the soil, crop genotypes and the management in a unified framework. So, the inputs are the weather inputs, soil inputs, genotype parameters of the crops and the management inputs. So, that gives the output based upon the user's interest. That enables the DSAT rapid simulation of crop response under the diverse scenarios, diverse agroclimatic zones, diverse soil properties, field conditions, weather. So, that you can in that case you can optimize your management for different scenarios. The system supports research, farm level decisions and policy analysis. So, you can go from the micro level to the macro levels I discussed also. So, that type of decision can be given using the DSAT model. So, DSAT forms a foundation of crop model, modern crop simulations and also decision making for the climate smart agriculture. As you know, now the climate change, the changing climate, rising temperature and the variable rainfalls, radiation that affecting the food grain productions. So, how we can have a climate adaptive technologies, so that we can come out with some of the management options using the DSAT modeling, and that can be tried in the also demonstrated in the normal farmers field to understand the effect of the adaptation technologies on minimizing the crop yield loss under the climate change scenarios. So, I hope this is the overview of these models. So, with this I thank you all.